You know, right, many of the databases in today's world are existing like RDBMS system. So, including Oracle SQL Server, let's say uh, Netezza, DB2. There are plenty of databases out there. So, why Teradata? That is a major question that everyone is asking that. Why Teradata? So, I think you might be hearing about these words in your college days or your study days, RDBMS and DBMS, right? So I just want to tell you about like what an RDBMS. Everyone knows that it's a relational database management system, and there is a scientist called core. They implemented 12 rules to satisfy for an RDBMS. Alright, so for a database to be an RDBMS, they have to follow the ANSI standard coding, that is American National Standard Institute, right? That is a standard that everything should follow with a language called structured query language. So that is called SQL or SQL. So any database is following these standards is called an RDBMS. Oracle, SQL Server, Netezza, plenty of databases are available, DB2 and Teradata. So Teradata is also part of this RDBMS only. It's no different from the existing anti-standard system. Only thing is these databases are various architectures with respect to their usage, right? And we see like as a traditional days, they load the data into a table, and whenever they want some reporting, they will try to run on the same database. But now the trend has been changed because as the data warehousing comes into picture, what happens is, for example, I'm a managing director or the CEO of the company, right? I wanted to do some kind of analysis on my data, so to take some strategic decisions. That is what the data warehouse purpose, right? Because why we need so much data for analysis? Because the data is already loaded by some other tools, and why we need especially data warehouse into our systems, because we should understand and implement the business based on the data that is available in the system, right? For example, there are front-end tools like SAP BO or Cognos or blah blah blah, right? So there are different tools available for the reporting purpose. Basically, the background might be a database, right? Obviously, it is like a SQL firing on these tools from the tools, from the front-end tools to the DBs like Teradata or Oracle, whatever. So whenever you fire a front-end query, obviously it will hit a backend with the SQL that is actually inherent from your reporting tool. That is nothing but your Teradata SQL or Oracle SQL, doesn't matter, right? A SQL will be fired on the reporting tools to get the required data. So what you will do with this data, right? So on average, for example, let's take Walmart client, biggest retail client in US and across the world. And for example, let's say product ID is their product name and the location, average sales, profit, something like that. I'm just giving the rough figures like in real time how it is like. So let's say product ID and let's say Nikon camera, location, cargo, average sales per month. Let's say $45,000, and profit is let's say 32% increase for the last 1 year. This duration is basically, let's say, for the 1 month. Okay, so I'm actually calculating the aggregate figures for 1 month. I'm seeing how much profit I have made on my product, and based on this one, I can take a decision. I mean, it's not like a complete granular level details I'm providing here, but when the report comes in, it will have very vast information to take something, a decision kind of stuff based on the data that you see. Otherwise, what happens is whenever my report, my inventory is done with this product, and if I wanted to order new inventory or something like that, I have to see somewhere the data like, okay, I have to order this product because this is the profit that I'm actually coming on this Nikon camera. So I have to order a few more in inventory because currently the stock is limited. So I mean, just giving an example like how the data will be used. Right. So based on this data, without this data, what happens if they directly go for the inventory, ordering more products, and the profit, if you see, it's actually decreasing from monthly wise, and you don't see any profit after ordering those products again to your inventory. There might be already products existing which were not sold, right? So in that case, what happens? You'll be ending up loss of business, right? That is just an example. Similarly, if you take healthcare domain, okay, I want to see my how I'm in, let's say I'm an insurance company, let's say Cigna Healthcare, right? So I'm an insurance provider to the third parties like the employees or some other group members, corporate members, and I'm providing the insurance to them, and they pay me the premium every month or every year. So I want to see how many claims that actually made by this person, so that I can actually see, okay, this guy is claiming more than what is actually paid in the premium. Let's say he paid the premium as $5,000 per year. It will be more like $2,000 per year. Okay, and you are actually incurring more expenses like because of the bad health or some diagnosis test or blah blah blah. So you might be spending $5,000 for that year. So what happens? Obviously, you have a risk of health, right? Because obviously, whenever based on the age factor and all, they provide the premium to your current health condition, and that means you're actually spending more than the yield limit. That is 2,000 is the premium that you're paying, and you're spending $5,000. Obviously, they're losing $3,000 per year, right? So what they'll do is they'll see your health history, like how you actually you're going, right? So you're actually going every month for diagnosis test. Let's say some complex health issues, let's say diabetes or something like this, and the patient is suffering from that, so he is going to undergo the diagnosis test every time, and $300 per month is spending on those things, and something like some diet plans, uh, some nutrition is actually meeting that, and he's spending $200 for the nutritionist to healthcare expenses. So including all these things, it is coming more than 5,000 per year. When I analyze this number into my data warehouse data, so I could see complete history of this member. Like let's say I want to see the 5 years of history data for this member. Okay. So in this case, I can see the entire member health history, and I can forecast how much he spent like last 5 years, how much he's going to spend for the coming 5 years, right? So I can actually estimate something based on that. I can suggest to the member to have some healthy diet plan or exercises, to recommend something to avoid these kind of expenses, to save my expenses, because I'm an insurance provider. Obviously, I have to pay to the providers. Providers are nothing but doctors or hospitals that I have to pay them when you spend something. So I will try to minimize that expenses as part of my insurance expenses, like by giving some health advice to you, or some giving some better diet plan, or our in-house nutritionist can contact you better for health reasons, and they can suggest you what not to eat and what to follow. So this is a real-time scenario. I'm just telling how the business works on the data warehouse. Correct? So any questions on this? You understand why we are using data warehouse first of all? Alright. So uh, to load this kind of data, so we should have some solid database layer to at the ground level to pull the history data. For example, 5 years of data is not a small thing. I'm talking about one member. If you're talking about one company or one employee group, you might be pulling some billions of records, right? Obviously, we should have some database which can, give better performance with respect to this pulling of the data, right? And Teradata is actually one of the best data warehouses, I mean the database servers, which can provide that optimization for you. It can actually pull billions of records with a fraction of seconds, unlike other databases. Because of the architecture, the Teradata that have the parallel processing. I will tell you while talking about architecture. So the parallel processing in Teradata is actually as an advantage for pulling kind of data that we use in databases. Okay. So obviously, when you say uh, the Teradata architecture, based on the way that they built the AMS and all the structure, so whenever we fire a query, the data will be pulled in such a way that it is actually taking very less time compared to other databases. So that is the biggest advantage of Teradata for, especially for data warehouse. And there are two types of systems like OLTP and OLAP. Uh, that I think you might know this, online transaction processing and online analytical processing. So basically, what is the difference between these two? Online transaction is nothing but if you go to a bank, you update your address or you withdraw some amount or you drop some check or something like that. The transaction will be immediately reflected onto your bank account. That is an online transaction. An online analytical is basically the data that is stored in the database which can be used for real-time analytics. That is nothing but your OLAP systems. So mainframes, these kind of systems they use OLTP because in banking system majority of the legacy systems are using mainframes for the real-time data updates. For example, as soon as you enter your bank and you deposit some money, immediately they update and it will be created within 2 minutes to your account, right? That is very fast and mainframes, such kind of the legacy systems are actually plays a major role in kind of online transaction process. And when you come to online analytical, so the data warehouse I'm telling you, right? So any data warehouse which can hold, huge information like the years of history, then actually, they can do that. I mean, they can use the database as a source system for them for the reporting purposes. Okay. So that is about the, introduction about data warehouse and Teradata. So uh, this is like whatever we discussed in just putting in a slide. This is also using the SQL and the Teradata as a shared nothing architecture. So here, what is meant by shared nothing architecture? So I'll just go to the architecture mode and just show you. Okay. So uh, this is a software that is having in Teradata that architecture point of view. So the main components are like parsing engine, the AMP, and your Binet. These are the hardcore components of Teradata and your disk storage. The AMP to store the data in the disk. So this is a complete node. The one node means one server actually, one Teradata server architecture. So everything will be driven by your parsing engine. So basically you write a query, right? Select star from table, right? Let me just quickly show it to you. So this is the Teradata server that you're going to work on. This is like a VMware player we need to have installed, and you can download the software from Teradata website version. I can provide you the software and installation guidelines how to do it. It's very simple. And provided that you have your latest processor like IP or i5 or i7. Okay, so this is the Teradata server I'm just showing here. So don't worry about the description of right now because the details and MLOs, the scripts can be written in the Teradata server directly. So right now I'll just show you a basic SQL, how your Teradata SQL assistant that you use in the real time. This is a tool that we're gonna work in real time. That is called Teradata SQL assistant. So this is my database, and I just default as even just put so that is like a database defaulting so that I don't need to write every time PBMS code David dot. Let's say I'm giving a query, basically for a stop for students. I got this data output. Okay, when I'm writing a query, I got this output. So how that happened? So when you talk about this architecture, right? So coming to your parsing engine, so the parsing engine have the different components like session control, parser, optimizer, and dispatcher. So when you send the SQL request, like select star from table, it will actually invoke a session, and based on the session, it will check for the syntax. Any syntax issues are there. For example, I say students dot, and I'm running this query. Okay, I say syntax error respect to something like a name or unique or something, right? So the dot is actually causing the syntax issues. How this come to know that I have a syntax issue in my table or in my query, right? So this will be read by your parsing engine parser. Parser basically checks for your syntax issues and your the way that you query. That is more important, right? Because it doesn't matter how much big the query, still the parsing engine will guide you whether if there are any syntax issues or something like that. And for example, if the table doesn't exist, let's say students some table name. So it will say table doesn't exist, object doesn't exist. So in this case, what happens? It is actually checking for the DB objects for this kind of table that is there or not. This is again being done by parsing engine. Yep. And optimizer. Optimizer basically uh, will tune your SQL request. Basically, tuning in the sense whenever you write a query based on the primary index and the indexing mechanism, whether you choose the right index or you have any problem with your query. So, I mean, how much time it is going to take and how much spool space. Spool space is nothing but the temporary space when you're writing a query. It actually builds in temporary space the data and will go for the results. That is called spool. So, in that spool space, if you check, okay, that spool is nothing but the space that is being replaced by the Teradata database when you fire the query. So optimizing will tell you how much efficient your query is and how much space it is going to use and what are the statistics of your query. All these things will be taken care by your optimizer in the parsing engine. This complete set is parsing engine, okay. And once the optimization is done on the query level, it will dispatch the request to the AMP level. So dispatcher is basically the name itself is self-explanatory there. Dispatching is nothing but your sending the data request to your the corresponding code data thing like AMPs, right? AMP is nothing but access module processing unit. This is a very very important component of Teradata apart from parsing engine. So once you're done with your dispatching, a binet is nothing but a medium of communication. It's just like transmitting the messages from parsing engine to the AMP level. It's binet is like a software and physical optical fiber cable as well. So it has both hardware and software. So when you see the Teradata server the real time, like how it looks like is more or less like this. I'll just show you the pictorial representation so that so here for example there are different servers and Binet is a cable that connects all the servers parallelly. So Binet has a capability of having multiple nodes into the same, I mean, into parallel units. So that what happens whenever your business is increasing, you actually add one more node to the Binet component so that you work parallelly without any disturbing the existing database. This is very very important feature of Teradata because the other databases, if you see, we cannot directly plug and play. So we have to shut down the database and hard backup, cold backup. A lot of things that we have to take care when you configuring increasing the database size from one size to other side in other databases. But in Teradata, we have a feature to actually add them parallelly in the binet. Alright? So this is Teradata database architecture. Okay. So when you come to the parsing engine here, the same thing can be done. The message will be passed by your binet and then to the different AMPs. So here, AMP is actually one more important component which actually does all the operation like the data thing. For example, you sending the data, sorting of the data, or saving the data, rows from the table, or aggregation. You do anything on the data, it will be done at the AMP level. So the AMPs will actually share the, I mean, not sharing exactly, the AMPs will work parallelly on the given SQL request so that what happens is the performance is very high. When you run all the, things parallelly, right? So the performance will be very high. Okay. So any questions here?
One question is there.
Yes.
For how many amps are the minimum? I mean, should be there for a one node. For one node,
Yeah.
how many amps are allowed?
Right. So there is no number as such, but currently if you see, if you want to see the existing database that we are using, there is a query to check the number of amps, hash amp. So here I have hash amp and hash amp plus one. Actually, you have to do plus 1. So normally we have 2 amps for the corresponding version that we actually loaded here. But in real time, we might have more than 2. It's not like 2 amps will be there. It depends on the database size that is actually built, and your DBA will decide how many amps are required for the system when you're building something new, right? So the DBAs will do that. So this is a count for getting the number of amps. Select hash amp plus 1. So here in this system that we are using, we have 2 amps. But in real time, you might have more than 1000 amps, 500 amps, depends on the size of the database. Because whatever we install is very simple, like 4 GB size, but in real time, it's like a terabytes. Okay, 5 terabytes, 10 terabytes, like 1000 terabytes. So based on the size, the amps also increase. Let's imagine 4 GB we have 2 amps, and 1000 GB is 1 terabyte, correct? Just
Yeah.
imagine how many number of amps based on that. So in real time, we might not see this 2 or 3. It might be more than hundreds or thousands. Okay, and this will be decided by your DBA once they design the database for your project. So they will check how much space is required for the application, how much data that is being used. I mean, approximately they will do some capacity planning and all before implementing the database. That will be taken care by your DBA. I mean, as a Teradata developer, we don't need to worry about the architecture and hardware level, but I mean, that is better to understand that you can always check in the database how many amps are available. Okay, by this formula. Clear?
Yeah, okay.
Okay, now uh, this is AMP, right? AMP will do all kind of the joining operation, segregation, and all the stuff, right? And your parsing engine will checking the syntax and optimizing the query. So what is meant by optimizing the query? For example, this is my output. If I just F5, I can get the output, and if I press F6, I will get the explain plan for this query. So the explain plan is nothing much generated by your parsing engine, will guide your the system how to do that, the database basically. So first of all, here it's saying that we do an all lamp retrieval. We lock the table for the reading deadlock on the table so that nobody can read at the same time. I mean, so that the lock will be happen on the table until it is released. Now we do an all lamp retrieval by way of all rows scan with no residual conditions, because all AMP rows is nothing but you scanning entire AMPs for your data. Select star from table name is very costly query because you're pulling everything from a table, right? Obviously, that is a worst query that we can write in real time, because we never want all the data from a table. That is ridiculous, right? I mean, until unless you really dumping something into some table, then only you can go for select star from table. So obviously you might need something only from the table which corresponding to your application or your project, right? So here it's saying that we do an all AMP retrieval with the step of by a way of all row scan. So your parsing engine will send the request through binet to AMP, and all AMP will be work parallelly to get your data for your students table. Let's say there are 8 rows in 4 amps, 2 rows each, and all 2 rows will be gathered back to your parsing engine in parallel, because every amp will work in parallel and no 2 amps will share the resources. Okay, that's why it is called shared nothing architecture. That is the reason the retrieval is very fast. Okay, for example, here if you see, it is an all amp retrieval and built locally on the amps, and spool 1 is estimated with high confidence to be 16 rows. So here it is saying that from students table we have 16 rows, right? So it will give some number of rows, and the space that is allocated should be something like 656 bytes. The spool one is nothing but the temporary space, and the number of rows would be 16 rows, and estimated time is 0.03 seconds. These are all rough estimates, okay? This might not be accurate all the time. Based on some different factors, we can make it accurate most of the time, but based on some criteria, this plan will not be accurate all the time. Even in Oracle also, you might see this explain plan or something like similar to that. But always this plan will not be efficient. I mean, efficient in the sense not completely 100% accurate. So, for example, if I show you the definition of the table, let's say show select star from table. That is to see the definition of the table. So here if I see the table definition, create table, blah blah blah, name, subject 1, subject 2, subject 3, 4 columns, and primary index on the name field, and different indexes on the other columns. So I will show you the difference now. Based on the primary index set. For example, select star from students where name is equals to. Let's see what is the data in this. Select star from students. Uh, let's say name is equal to Joel. Okay, so if I execute this, what happened is I'll get some 2 or 3 rows maybe, right? And if I see the explain plan for this, so if you see the explain planning now is very different compared to the earlier thing, right? Here it's saying we do a single amp retrieval by way of primary index with no residual conditions, and the size of this pool one is estimated to be constant to 7 rows. But ideally we got 3 rows, but that's what I'm saying. It may not be accurate all the time. The estimated time for this is 0.02 seconds. Now, why it is a single amp operation? Okay, you see the difference, right? Earlier it is like all amp operation. Now it is a single amp operation. So, what is the difference between single amp and all amp? Single amp will be always faster, right? Because your data, whenever you define a primary index in Teradata on a column, all the corresponding primary key values will be stored in one amp. So that whenever you search based on your primary index in your query like where clause or something like join condition, also you're using the primary index, what happens is it will improve your performance because it will only use single amp operation. Okay, instead of searching in multiple amp, single amp will be always faster, right? You agree with me on that? Right? So based on the primary index that we chosen here, it's a single amp operation. Okay. Any questions here? So
No.
always whenever you choose a kind of indexing mechanism in Teradata, it is always faster than the different way of fetching the data. That is a key point in Teradata. Everything is roaming around your indexing part. In Teradata, there is no primary key concept like in other databases. It's like a primary index and secondary index, and there are plenty of indexes available in Teradata. We'll be going in detail like once we go into the SQL part of it. Right now, I'm just giving an overview like how the parsing engine will work. That's why I'm just showing the queries like on the explain plan to show that how the parsing engine will effectively frame the query based on your given condition. Okay, clear on this explain plan? I mean, for now, at least on high level on the parsing engine and architecture. Any questions? And as I told you, BINET is a point-to-point communication between your parsing engine and AMP level. So it has like both hardware and software. So hardware will be used to connect multiple nodes, and software will be used whenever you use a single system. For example, a standalone database like that we are using right now, it have indirect BINET software in that to communicate to the parsing engine and the AMP level. But when you use multiple nodes in the server's real time, you might need a hardware cable like an optical fiber cable to connect two nodes. Okay, in real time systems that will be like, I'll just show you the sample picture here. I think this is a way how it looks like. Okay, real time. This is one Teradata server. Whatever we installed is here, right? That is one server. We can have 1024 nodes. Now it is actually supporting 1024 nodes for a single BINET. Okay, the BINET can support 1024 node. That means we can actually configure roughly 1000 Teradata nodes in a single time. That means you can store very huge information. And for information, Walmart is the biggest data warehouse in the world as of now, from a data warehouse perspective. After that, we have some different banks, Bank of America, JP Morgan. They use also Teradata, and healthcare industry like Cigna, Anthem, USG, and everybody using Teradata. And like Teradata, the disadvantage of Teradata is little expensive compared to other databases. To increase 1 terabyte space also, like you need to pay some millions to Teradata operation. So that is the only thing that is there with the database. I mean, the costly, that effectiveness is only the disadvantage. Otherwise, it is good compared to other databases. And of course, the performance is also really heavy. That's why the people still go for Teradata. The bigger companies, I mean to say. And of course, you don't see medium or small enterprises might be using Teradata. Okay, only the major giants. And of course, if they have some limited data, they can go for smaller versions of Teradata as well. Alright. So any questions on the architecture point of view? Okay. So if no questions, then I can go for the course content and the duration and the details. So like for example, introduction and architecture will cover, in two process, and then we'll talk about space management in Teradata, how the temporary space, school space, and the different type of locks and fallback mechanism from the second part. And the third one is the data distribution, like how exactly the data will be distributed. Right now I show you the primary index, right? Similarly, we have PA, nothing but primary index, non-unique primary index and unique primary index, row hashing algorithm, how it will work, secondary index in Teradata, and what is the difference between primary key and primary index, hash map and hash index, primary index, and data retrieval in USA and NUSA. USA means unique secondary index, non-unique secondary index. NOPM is no primary index. Okay, we will because Teradata hardcore subject is around indexing. That's why we have to very much thoroughly exercise on the indexing part, because in your real time, your query completely depends on the indexes. How exactly you define your table and what type of join that you're using. Okay, because Teradata, if you see the real-time query, you might be using multiple tables in a single query with different kind of left outer join, right join, inner join, but still you can actually pull the data with the right kind of join and right kind of indexes. Doesn't matter how big the query is, still you can get the data. Only thing is you should use proper joins and stats also. I will tell you what is stats. Okay, this is about indexing. And now the other plan is like how to read explain plan. Explain plan in nothing but I just show you, right? Another indexes apart from primary and secondary, like partition primary index, join index, partition index, hash index. We'll talk about these indexes as well. Okay. After that, the important concept of collecting stats. Stats are nothing but the statistics in Teradata. How to collect the stats before you go into a table definition, I mean into production, because collecting stats is very important. Otherwise, you will be running out of the spool out issues. Spool out in the sense, for example, select star from table. And I just show you the query, right? You have a big table like billions of records, and you write select star from table, it will spool out. And even you're selecting some columns which are not primary index in there and you don't have any conditions, it will spool out. Until unless you have defined the statistics on the column. Statistics, I will tell you what is exact meant by that and how to collect the stats and what is the main role of statistics in Teradata. I mean, statistics is nothing but the number of unique rows of a table, okay, in a high level. So for example, I have a table called employee table. I have 10 rows, and today I have 10 rows. Tomorrow I might be loading 50 rows. So total is 60. And if I don't collect the stats on the table, what happens is it will passing engine will still think that okay, I have this table. Last time updated when it was updated for the statistics, I have 10 rows. But right now it is 60 rows. But parsing engine doesn't know that until unless you refresh the statistics. Okay. So that is a problem with the stats. If you don't refresh it regularly, parsing engine will still think that okay, I have only 10 rows in this table, so I can give this much full space and this is my confidence. And when you define a statistics and refresh, like after 50 rows update, you refresh the stats again, and your parsing engine will come to know that okay, I have 60 unique records in the table, therefore I can actually estimate this much spool and these many rows. That is how the statistics will play a key role. Okay, so we'll talk about that in detail in the classroom. That is about statistics, very important concept, and high, low, no confidence, and performance tuning. It basically depends on these as well, right? And the SQL. This is your hardcore, your Teradata component. We'll talk about data type function, different function caching, string and date functions, group qualify, very, very important, rank and row number, okay, partition clauses, very, very important these two. Real time we might be using very frequently. And this is a SQL. Once we cover the SQL, we'll cover the utilities, which is another important concept of Teradata because no other database have kind of utilities that Teradata. BTech is basically 70% of your work will be done in BTech. Okay, in your Teradata real-time environment, you might be completing your 70% of work in BTech scripts only. And the other utilities like fast load, mload, TPT, the new one. So these utilities plays a crucial role in Teradata environment. So we'll be talking about each utility in detail with example scripts and practicing as well, hands-on uh, sessions. Because I have a Teradata server where I can just show you for each and every script how it will work on a real-time scenario with example of scripts like this. For example, the variables and the TPT script. This is a TPT script. I have other BTech mload examples. I can show you how BTech work and how the BTech logic works and all the stuff. Alright. So this is about the utilities that we use in Teradata. So the utilities should be only practiced in Teradata server, and this is a SQL extension where you can write your queries for all your SQL. You can write here, and only the utilities you can practice in the server. Okay, that is about the course content. After that, best practices, coding standards, some real-time case study questions, solutions, right? Some examples.